So we are given the following function. In part A, we need to use the 3-digit rounding arithmetic. The assumption that e to the power of 1.53 equals 4.62, and also the fact that e to the power of px equals to e to the power of x to the power of b. And we need to evaluate f of 1.53. So let's start by doing part A. I'll write down right here part A. We will rewrite our f of x. I'll just copy paste it actually. So this is our f of x. So now the first thing which we will do, we will use this fact that we were given in part A, this one, to rewrite our f of x as f of x equals 1.01 times e to the power of x to the power of 4 minus 4.62 times e to the power of x to the power of 3 minus 3.11 times e to the power of x to the power of 2 plus 12.2 times e to the power of x minus 1.99. Well, now we need to calculate f of 1.53. So we will just substitute 1.53 for all x's, and we will get 1.01 times e to the power of 1.53 to the power of 4 minus 4.62 times e to the power of 1.53 to the power of 3 minus 3.11 times e to the power of 1.53 to the power of 2 plus 12.2 times e to the power of 1.53 minus 1.99. Now since we know that e to the power of 1.53 equals 4.62, we were given this information. That means that we can substitute 4.62 for e to the power of 1.53. So we get that f to the power of 1.53 equals 1.01 times 4.62 to the fourth power minus 4.62 times 4.62 to the third power minus 3.11 times 4.62 squared plus 12.2 times 4.62 and minus 1.99. So now we have this expression, and the last thing that we need to do is just to evaluate it. So to do all the calculations here, let's rewrite it as f of 1.53 equals, so 4.62 to the power of 4 equals 455.583, so it will be 1.01 times 455.583 minus, right here we have 4.62 to the fourth power, so it just will be 455.583 minus 3.11 times 4.62 to the squared equals 21.344, and 12.2 times 4.62 equals 56.364 and minus 1.99. Well, now let's find this value. So the first part will be equal to 460.139 minus 455.583 minus 66.380 plus 54.374. Well, now again, after doing all the calculations, we get negative 7.45. So by using this method, f of 1.53 equals negative 7.45. Well, now let's move on to part B. So for part B, we need to calculate the same thing. So we need to calculate f of 1.53, but we need to use polynomial factoring technique. So again, let's copy paste our f of x. And now, if we look at f of x, we can see that this function can be factorized as f of x equals 1.01 times e of x plus 1.715 times e of x minus 0.173 times e of x minus 1.415 and times e of x minus 4.702. Now we just need to substitute x, substitute 1.53 for x and use that e to the power of 1.53 equals 4.62. So we will get that f of 1.53 equals f of 1.53 equals 1.01 times 4.62 plus 1.715 times 4.62 minus 0.173 times 4.62 minus 1.415 times, let me move it a bit, times 4.62 minus 4.702. Well, again, we just need to do all the calculations, and then we get that it's equal to 1.01 times 6.335 times 4.447 times 3.205 times negative 0 times 0.082. Again, we do the calculation and we get that it equals negative 7.478. So by this method, f of 1.53 equals negative 7.478. Well, now in part C, we need to calculate percentage relative errors to the true result, and we are given the true result here. So the true value of f of 1.53 is negative 7.60787. So to calculate the percentage error, we usually write it down. We usually use letter sigma to write down this percentage error, and we will use the formula of percentage error, which looks like this. It's the absolute value of VA minus VE over VE and times 100%. So here VA is actual value observed. VE is expected value. So for part A, the actual value observed was negative 7.45. So VA equals negative 7.45. And the expected value was the same for both part A and part C. This is negative 7 point right here. Well, I'll just copy paste this number. So here is the expected value. Well, now to calculate the row, we'll just substitute VA and VE. We'll just substitute the numbers for VA and VE in our formula. So sigma equals as the absolute value of negative 7.45 minus negative 7.60787 over negative 7.60787, and the whole thing is multiplied by 100%. So this actually will be equal to, if we do all the calculations, it equals 2.075%. So this is our error in part A. Regarding part B, we do the same thing, but now actual value equals negative 7.478, and expected value is the same. So sigma equals the absolute value of negative 7.478 minus negative 7.60787 over negative 7.60787. The whole thing is multiplied by 100%, and this is equal to 1.707%. So actually the error in part B, so by factorizing, by a polynomial factoring technique, is smaller in this case.